Hi students, welcome back to my channel Evolve Solving Physics. In previous class we have discussed some types of vectors. There are some more types of vectors that we are going to discuss in this class. So another type of vector is unit vector. What is meant by unit vector? Unit vector means a vector whose magnitude equal to 1 and use it to specify a convenient direction is called unit vector. As we all know that vector means having magnitude and direction and should obey the law of vector addition. But unit vector means the magnitude should be equal to 1. And this unit vector is mainly used to specify the direction of a vector. So magnitude of a given vector should be equal to 1 and this unit vector is used to specify the direction of a given vector. And this unit vector has no units and no dimensions. Unit vector has no units and dimensions. As we all know that each vector contains a units, but this unit vector did not have any units and dimensions. And mainly important that unit vector is used to specify the direction of a given vector. Direction of a vector. So how you will find the magnitude for a given vector? So that we will discuss in next class. As you all know that the vector is denoted by a bar and magnitude of vector is denoted by, this is the magnitude symbol, determinant symbol. This is the magnitude of a vector. This should be the given vector whose magnitude should be equal to 1. That vector is called unit vector. And unit vectors are denoted by alphabet with cap. So this cap represents unit vectors. So any alphabet denoted with a cap on alphabet, that is called unit vector. So magnitude with direction represents vector. This is the magnitude of vector. This is the unit vector. You all know that Cartesian coordinate system means 3 coordinate system, x, y and z. This is the Cartesian coordinate system along 3 axes, x, y, z axis. So for this Cartesian coordinate system, unit vectors along positive xyz axis. You all know that you have positive axis and negative axis. For a positive axis, the unit vectors are denoted by I cap, j cap and k cap. I said that unit vectors are denoted with caps. So these unit vectors for 3 coordinate axis, xyz axis, positive xyz axis are I cap, j cap and k cap. So for x axis the unit vector will be I cap, for y axis the unit vector will be j cap and for z axis the unit vector will be k cap. So everyone should remember that this is the very important point. Along 3 axes the unit vectors will be I cap, j cap and k cap. You all know that. So for x axis the y axis will be perpendicular and for these 3 axes they will be mutually perpendicular to each other. So the magnitude of unit vectors will be equal to 1 when the magnitude of unit vectors equal to 1 because the 3 coordinate axes are mutually perpendicular to each other. For suppose x, y, if we consider x and y axis, these 2 axes are perpendicular to each other. So the magnitude of these vectors, these unit vectors will be equal to 1. Sir, when the three axes are mutually perpendicular, so when three axes are mutually perpendicular to each other, the magnitude of unit vectors is equal to 1. So this is the one of the important point, that the magnitudes of unit vectors equal to 1 when the axes are mutually perpendicular to each other. For suppose in any problem solving, the magnitude of unit vector along x-axis is equal to 1. I said that unit vector means the vector whose magnitude is equal to 1, that we call it as unit vector. What is meant by null vector or zero vector? The vector whose magnitude is equal to 0, that is called null vector or zero vector. A vector whose magnitude E is equal to 0 is called null vector. So null vector, we can call null vector as zero vector. So whose vector magnitude is equal to 0 means that is an null vector. So examples for null vector means a object velocity is constant, or the velocity of an object is 0, that we call it as null vector. For suppose if an object is moving with constant acceleration, uniform acceleration, stationary, the object is stationary, that are the examples for null vector. So if an object is uniform or stationary or constant or rest, that will be the examples for null vectors or zero vectors. So addition of null vector with any vector will get any vector. So multiplication of null vector with any vector will get a null vector. So this is about null vector and unit vector. So next vector is position vector and displacement vector. So as we all know that we have discussed in motion in a straight line that the position of an object can be explained with the help of, or the position of the object can be known with the help of origin and coordinate axis. So to know the position of the object, here we are taking the origin O. Here P and P dash are the positions of the object for time T and T dash. So the object is at position P, the time taken is T from the origin. So and T dash is the time taken by the object to reach the point P dash from origin. So P and P dash are positions of the object at time T and T dash. So now we are going to find the position vectors for the point P and P dash. Now draw a straight line, or draw a straight line from origin to point P. So and draw an arrow here. So this represents magnitude of an object. The line represents magnitude and object, and arrow mark represents the direction of the object to reach the point P. So the direction is representing the object position here. So this is the position vector. So OP is the position vector denoted by R bar. So this is the position vector for O to P. So here the line represents magnitude, arrow represents direction of the object. So OP is the one position vector, that is r bar. So just remember that position vector is denoted by r bar. Small r bar represents position vector. So now join the O P dash with another straight line, and the position vector will be r dash bar. So here we have two position vectors, that is r bar and r dash bar for times t and t dash. So the object moving in two positions, that is p and p dash. So the position of the object can be represented with a position vector, that is OP bar equals to r bar. So OP dash bar equals to r dash bar. So for time t and t dash. A straight line joining p and p dash represents displacement vector. So the motion of the object from p to p dash, that is called displacement vector. Means the tail of a vector at p and tip at the p dash. So the motion of between two position of the object can be represented as displacement vector. So as we all know that the position of the object is here is p and p dash. The line joining between these two position of the objects represents displacement vector. Origin to any position of the object with direction represents position vector. So origin is important here. Origin and coordinate axis. So line drawn from origin to any position of the object with direction represents position vector. So the distance or a line drawn from two positions of the object between two times is called displacement vector. So polar vector. What is meant by polar vector? A vector having starting point or point of application is called polar vector. So as we all know that every object is moving, means we can know the starting point of an object. For suppose example for the polar vector is force, momentum, acceleration. Momentum and acceleration can be known with the help of applied force. Without any force we can't find momentum, acceleration, velocity. This is a pen. If we apply a force on the pen, the pen will move in the direction of applied force. So we know the starting point of an object where we are applying a force, that is called polar vector. So you should know the starting point or point of application of an object. That vector is called as polar vector. So in this polar vector there will be no change in the direction of an object, even there is a change in coordinate system. If there is any change in the coordinate system but the object direction does not changes, that vector is called polar vector. So next vector is axial vector or pseudo vector. Axial vector can also be called as pseudo vector, which represents rotational effect and acts along the axis of rotation. So the object which have an rotational effect, for suppose if we take an example of top, we call it as bongaram in Telugu, top. So if we throw a top, it will rotate along the axis. So it will rotate like this, rotation. So any object which have rotational effect, that we call it as axial vector or pseudo vector, and the object direction changes with the axis. In polar vector there will be no change in the position or direction of an object, even there is change in the coordinate system, but according to coordinate system the object direction will changes here in axial vector. So any rotation effect represents axial effect. Angular vector, angle examples will be angular velocity. Angular velocity means that represents rotational effect. So any angular represents rotational effect, torque. So torque that we will discuss in future classes. So any rotational effect of an object represents axial vector or pseudo vector. So top is the best example for the axial vector. So these are the important vectors which will be useful in problem solving, that is like unit vectors, null vectors, that are very important vectors which will be very useful in problem solving. So vector is represented by alphabet with an magnitude and direction arrow mark, and unit vector is represented by cap. A scalar is represented by an alphabet, and these are the symbols for the vector, unit vector and scalar. So if you have any doubts, please comment me in comment box.